Good afternoon. Today, I would like to solve one task about 8051. But as you can see, we have a new application, to be more exact, new simulator called 8051. There are more simulators for 8051, such as called Proteus, but as the beginner, it's better to learn 8051 instructions, programs, more details using 8051. And later on, we will come to the Proteus simulator, okay? So now let's take a look. What do we have? We have system clock. In other words, that's the frequency of our instructions. System clock provides us the timing signal for the execution for our instructions. You know, um, Whenever we open Edsim51 simulator, we can see that system clock is already set to the 12 megahertz because uh, 8051 uh, executes one machine cycle, which is 12 clock cycles. So at 12 megahertz, one machine cycle is 1 microseconds. Why 8051 executes in 1 microseconds? Because for our eyes, uh, how to say, it's better to realize and see the modifications in our program, especially when we work with the RAM table, when numbers are changing here. But let me give you a more clear example. Let's say we have eight LEDs, okay? In other words, let's say we have eight lamps. And our task is to turn on the first one, and 1 second later we want to turn off it, and then go to the second one. It should be on, off, third one on, off, etc. If we do it in 1 microseconds in the 1851, we will see the modifications. We will see how the lamps are turning on, turning off, step by step. But if the frequency is 1 second, it's gonna be so fast, so much fast that we won't even realize that LEDs were actually on. You see the difference. So it's better to set our frequency at 1 microseconds. But it's not only 1 microseconds. You can change it to 10, 500. It's up to you. But more frequency, more faster the execution. Okay. Next, we have general purpose registers such as R0, R1, R2, and then we have B register, where we use for the division, multiplication instructions, accumulator, and what else do we have? Data pointer, stack pointer, program counter, interrupt registers, T high, T low. We will learn all of them, but not in this video, in further videos, okay? Next, we have data memory table, in other words, internal RAM table. It has locations from 00 to 7F. As I told you, these ones are LEDs. And below you can see there are 4 characters. It's called 7-segment display. There we will represent our numbers, characters, and so on. All right, so let's come to the task. Write an 8051 assembly program to compute the length of the string defined from the address 40 hexadecimal and store it in the length variable. So, for example, let's say we have a string called mouse, okay? There are 5 characters, and we want to count the characters and store it in the length variable, okay? You understood? So, first of all, let's declare the variable length with the keyword AQ, which means equal, 30 hexadecimal. You can change the location like 31, 32, 50, 60, 10, but not 40, because in this case we are already busy with 40 hexadecimal with the string, okay? Next we have move instruction, 40 hexadecimal. uh, M, okay? Move 41 O, move 42 hashtag, sorry, it should be comma. O, move 40 hexadecimal. S, move 44 hexadecimal, hashtag. E, move 45 hexadecimal. I'll explain you why right now I'm writing 00 hexadecimal. Next we have move R 0 hashtag 40 hexadecimal, move R1, hashtag 00 hexadecimal. So, this part is understandable because we are just assigning our characters to the each of these locations, 40, 41 to 44. And if we don't put 00 in the end of the string, it's called null terminator. Our program will count the characters, even though not existing characters, infinitely many times, forever. So we need to stop. Assembly is not high level language, it's low level language. So we need to pay attention on everything. We have to put limits there. All right. Next, on the next line, we just assign the first character M 40 hexadecimal to the R0 register, and R1 is going to represent count. Okay, so now let's write the loop label. Label is like method in Java or function in Python. Okay, so move, as I told you, we're gonna work with accumulator most of the times. Mm, R0. This sign means that the value of the location of the current location of the R0. Right now, R0 is in the location of 40 hexadecimal. This sign gives us the value of this location, which is M. Okay, so right now A is M, and if accumulator uh, is 0, so we have to finish it. We have to stop the counting. But as soon as it's not 0, we have to just increment our R0 to go to the next character, iterate through each character, okay? Increment R1, count, okay? And then move vertex small R1. So as soon as we sorry after we iterate all these characters, we come to the 45 hexadecimal and see the value of this is 0. So if accumulator is 0, then we jump to the jz means jump if 0, yeah. So we jump to the end accumulate sorry end label, and we see that R1 is already 5 and R5 is set to the 30 hexadecimal. Now let's run the program and see. Assemble, step. So 4D. Right now, M is in the location 40, 4D. Have you ever heard about ASCII code table? So M is located somewhere. Let's actually check because I don't remember the value of M. 109, but actually uppercase is 77. Okay, but the thing is why it's 40, because it's our hexadecimal version of the RAM table. We need to just convert our decimal 77 to the hexadecimal. How do we do it? We all know it. 77 divided by 16, and you know the steps. Next instruction 6F, that's going to be O, U, S, E. And then right now, as you can see in the 00 location, we have 40 location. Excuse me. Actually, I forgot to write the really important jump. We have three types of jump in the Edsim51: S jump, L jump, and A jump. Short jump, line jump, and absolute jump. Actually, I won't talk about absolute jump, but I will talk about short and line. Short has a range of minus 127 and 128 bit. But what about line jump? It has much more, like 64 kilobytes. I don't remember actually. But in this case, let's use L jump, and we jump back to the loop to count again, iterate, through each character. Assembly step. Sorry, I think it's lagged a bit. Okay. So you see right now our how to say in the position of 30 hexadecimal, our count is 05, which means 5. Yeah. So we have 5 characters, and that's our representation of the mouse string in ASCII code. Yeah, that's how we solve this question in the 8051. Thank you for your attention.